You've worked so hard to get your environment up and running. But you have to remember that everything you've done is only in your running config. Show running config. So let's just compare some information here. Let's go down to our actual RIP configuration information. Something that we can easily remember. Let's go down a little more and see we have passwords on our console lines. We have passwords on our VTY lines. We have DHCP set up. We have an enable secret and an enable password. What happens if my device loses power right now? Everything in the running config goes away. Why? Because the running config is stored in RAM, which is volatile memory. You lose power, you lose what's in RAM. The startup config is in NVRAM. And we want this to be an exact copy of the running config, if that is the running config we want. Because NVRAM is non-volatile. And since it's non-volatile, and the startup config is in the NVRAM, then when the router loses power, reboots, is reloaded, then the configuration information that's in the startup config will be loaded. So let's take a look here. I don't see any enable password or enable secret. I do see my DHCP pool information. All right, but it's different. It's different than what we actually configured. All right, so this is old. Definitely old information. Let's go down a little further. I don't see any RIP configuration information at all. I don't see any console passwords or VTY passwords. So if something happens to this router and we lose power, I lose my configuration. I'm going to have to start from scratch again, and I don't want to start from scratch. So what can I do? Copy running config to startup config. That is how we back up the contents in RAM to NVRAM. So now if I take a look at my startup config, show startup config, we can see here, oh, look at that. There's those passwords that we had configured. There's some DHCP information. All right, much better than what we had in our startup config before. Go down a little further, we can see that there's the passwords for console 0 and VTY 0. So, great. This is perfect. We now have a backup of our running config in our startup config. So you've backed up your running config to your startup config. How safe do you feel right now? I hope you don't feel all that safe. And here's the reason why. Although your configuration file is in NVRAM, what happens if your router totally blows up on you? Let's think about it. Let's say NVRAM gets damaged and the router shuts down. When you turn it back on, your configuration's gone. What if you can't access the startup config at all? And something happens to your router, or you have to replace your router. So you bring a new router in. You plug it in. Do you have a configuration file? No. It was an NVRAM on the old router, and I can't access the NVRAM on the old router anymore to get it. All right. What can we do? We need a storage location, some type of server that can hold our configuration files. The simplest solution is a Tftp server. Let's go ahead over to PC1. PC1 right now is configured as a TFTP server. I actually went out and downloaded a free TFTP server, the SolarWinds TFTP server. There's many different TFTP servers out there. I'm not promoting this one specifically. Go ahead and get whatever you want. But I've configured it right now to act as my TFTP server, and all files are going to be stored in my TFTP folder. So there's not much to it, and I actually have the service started. So it's actually running in the background. So let's go ahead and see how I can copy my startup config to this TFTP server. So go back to R1. First and foremost, what is the IP address of PC1? Well, if you don't know, let's go check it out. It is 10.1.1.4. All right, so let's see if we can actually ping 10.1.1.4, because if we can't ping 10.1.1.4, then I'm definitely not going to be able to utilize TFTP and connect to it and transfer my configuration file. Great. All right. So I can successfully ping 10.1.1.4. But how do I actually copy that startup config file over to the TFTP server? Let's do that right now. It's a rather simple command. Copy. Copy what? Copy the source. What is my source? Wow. There's a lot. There's a lot. A lot of options. What I'm looking for is my startup config. Copy from my startup config. So my source. Copy startup config. What's the destination going to be? That's what we're looking for next. In this case, I'm going to say TFTP. And that's it, folks. Go ahead and hit enter. You have just specified I want to copy from the source of startup config, and I want to copy it to a destination of TFTP. Now it's going to ask you, what's the actual address or name of that TFTP? No I there, but let's call it just R1 in this case. So I can change that. If I hit enter, it accepts the default, but no, let's call it R1. We'll hit enter there, and that's it. I successfully copied the file from R1 to the TFTP server. Let's verify that. Look at that. It's in the TFTP folder on my TFTP server. So let's say we've gone out, purchased the exact same router. Now we need to get the configuration information back onto R1, just like we had it before. So we want to copy that configuration file from our TFTP server into the startup configuration of R1. So let's go ahead and take a look at how we can do that. So we have to make sure that we can ping the IP address of that TFTP server. So we do have successful connectivity to the TFTP server at 10.1.1.4 in this particular case. All we need to do is use our copy command. Copy from what source to what destination. In this case, we're copying from a TFTP server to our startup config. Let's go ahead and hit enter and see what they ask us. Address or name of remote host. Well, that's going to be the IP address of our TFTP server. What is the actual source file name? All right. Let's go back to that TFTP server and remind ourselves what that file name is. It's actually R1. So let's go ahead and put R1 in here. Destination file name, startup config. Yep, that's where I want it to go. Accessing TFTP, loading, Everything's successful. Great. That is perfect. So now I've successfully copied over that configuration file from the TFTP server back to R1. So remember, the copy command is copy source from what to what. Let's do two things here. First and foremost, I want to show you what happens when we erase our startup config. Don't want to use unless you have to is the reload command. Do you really want to go over to your switch and unplug the cable and plug it back in? No. You're not going to do that with a PC. With a PC, you click restart in order to restart the PC softly. Well, that's what reload is here. Let's reload the actual switch by the console connection. Why? Because I typed in the reload command. We can see here that it's recognizing its base Ethernet image.bin extension. And what's it doing now? It's actually extracting, decompressing the actual image and loading it into RAM. That's what it's going to be doing here. So we'll let it finish here, doing its actual extraction process and loading it into RAM. And as we can see, it's done now. And then it's going to continue to boot the device now. It's actually booting this iOS image now, loading it up, doing a power on self-test, taking a look at the CPU, the memory, the different interface cards that we have to make sure that everything is operating as it should be operating. Just like a PC goes through a power on self-test. A little bit of cryptography as it should be operating. Just like a PC goes through a power on self-test. A little bit of cryptographic information here, warnings about importing and exporting the actual device. And then we can see a summary here. A summary based on the different interfaces that we have available on our actual switch. 1 virtual interface, 24 fast Ethernet interfaces, 2 gigabit Ethernet interfaces, the actual processor that we have, a PowerPC 405, the actual amount of memory that is available on the switch. It's going to load a bit more here. We can see our actual model number as well. Then it's telling me to press return to get started. Last time I checked, I only had an enter key on my keyboard, so I'm going to use enter instead. Some more initialization here of different features and services. All right, let's go ahead and hit enter to get started. Whew, look at this. System configuration. All right, let's go ahead and hit enter to get started. Whew, look at this. System configuration dialog. What is that? Why do you think we received this system configuration dialog message? I don't have a startup config. My switch looked in NVRAM for a startup config file and did not find it. Therefore, it has no configuration that it can load. We're at factory default settings now, folks. Would I like to enter the initial configuration dialog? The answer to that is no. We don't want to enter the initial configuration dialog. It really is just a mini type of little setup wizard. Would you like to specify a password? Yes or no? Would you like to... We don't want to enter the initial configuration dialog. It really is just a mini type of little setup wizard. Would you like to specify a password? Yes or no? Would you like to specify an IP address for management purposes? Yes or no? Would you like to do this? Would you like to do that? I just say no to absolutely everything right here. And let's get into the switch. And let's actually start manually configuring this switch ourselves. Let's think about what we need if all of a sudden we have a failure within our organization. For example, let's say ASW1 goes down. ASW1, well, we're going to need a new switch. So what type of switch is ASW1. We use the show version command to see that. Show version. It's telling us it's a 2960 catalyst switch. Let's take a look at our specific model number, the WSC296024TTL. So we need a replacement device. Either we could have a supplier on hand that is able to provide us with this product within a couple of hours of failure, so they have them on hand, or maybe we've already purchased them and they are sitting on the shelf within our organization. It doesn't matter what you use. Just make sure you choose the best method for your organization for those spare parts or those backup devices in case of a failure. But what else might we need? Well, we're going to need our actual configuration file backed up. So let me go do that right now. Copy startup config to TFTP. Interesting. Let's check it out. Show startup. Wow, we haven't even saved anything on ASW1 right now. Let's do that. All right, so I've copied that over. But what else might I need? What else might I need stored on that TFTP server if all of a sudden ASW1 totally fails and I have to replace it? What about my iOS? My Cisco Internetwork Operating System. Let's see, what is the name of that? It's stored in Flash. And here's the actual file. So let's look in Flash right now to see what I have. Show Flash. All right, I actually have two different iOS images stored in Flash right now. I got an older 12.2 code iOS, and I got the newer 15.0 code iOS. Well, I want to copy this iOS to a TFTP server. I have this image available to me on that TFTP server, and I can just copy it over and upgrade ASW1 to the latest iOS. Let's go ahead and do that right now. Copy, in this case, Flash to TFTP. Source file name. What is that? What's the source file name in Flash? Let's just copy and paste it right out of Flash. Go ahead and hit enter. What's the name of our remote host? So the TFTP server, 10.1.1.4 is its IP address. Destination file name? Yeah, let's call it the exact same thing. Let's go ahead and hit enter and copy it over. Now this process, we have successfully completed it. So now I have a backup of that iOS image on my TFTP server. Let's take a look at that. And there it is right there. The C2960 land-based K9MZ150-2.se.bin file stored on the TFTP server. So now I have my configuration file on the TFTP server, I have my iOS image on the TFTP server, and I have some type of agreement with a supplier to replace ASW1 if something happens to it, or I have one on my shelf right now collecting dust, just waiting for its turn to join my network. And let's take a look at our Flash. So show Flash. We already have that image in our Flash, so let's go ahead and remove that image right now, just for demonstration purposes. So delete Flash, and there we go. Delete, sure, let's do that. Confirm, perfect. Let's go ahead and let it delete that particular image out of the Flash. Should be gone now, so show Flash. All right, it is gone. Let's now pretend that we have downloaded the latest and greatest iOS image, and we have put it on our TFTP server right here. And now we want to upgrade ASW1 to this iOS image. How can we do that? It's the TFTP server. And then once we find that TFTP server, it should start copying. Alright, so this will definitely take a while, considering the size of the iOS image. So we'll go ahead and pause here, and we'll come back when it has successfully loaded. Alright, so as we can see here, we have TFTP server. Let's take a look at our flash now. Show flash. And we can see that we have both images stored in flash. Now, here's something we have to make sure of. We have to make sure that we tell ASW1 which image to load. Here's the reason why, because maybe we still want to use the 12.2 iOS image. But what will happen during the boot process is that the device, ASW1 in this case, will load the first image it finds in Flash. Literally, folks, it's going to look in Flash and say, oh, there's a .bin, good enough, let's load it. And it's going to ignore the other one. What if I wanted 12.2 to load? Go into global configuration mode and use the boot system command. What file do I want loaded? In this case, let's say I wanted 12.2 to be loaded. That's what I would specify. What if I want 15.0 loaded? That's the one I would specify. So although it searches for and uses the very first image in Flash, and in this case, 15.0 is the first image in Flash, I'm still going to use the boot system command to actually tell ASW1 what image I want it to boot. So show boot, if I recall correctly, should tell me what I'm using. Yep, there we go. Boot path list, LAN base K9, 15.0, looking good to me.
You're starting to realize that we're going to wind up typing commands on a router or a switch.